we talk about these commands, we say they are modal commands. Modal means that they remain active unless they are cancelled by another command. So these next line, which is saying z, just giving z value 0.1, means it is still using the G00 command. So this next line is also a rapid move down to z is equal to 0.1. So it's still a G00 to z is equal to 0.1. So we say that depending on where the 2 is located, there are two basic rules to follow for safety's sake. That is, if the z values represent a cutting move in a negative direction, then the x and y axis should be executed first. Now, if the z value represents a move in a positive direction, then x and y axis should be executed first. That is, this is not really a big issue here, but if you want to move the work out of the 2 out of the workpiece, just as we saw, this is very key. That is, this z axis first and then the xy plane when you are going away from the away from the workpiece. So that is more overrides these ones. So for instance, let's take a sample program and look at what is happening within the sample program. If you take a typical CNC program, I'm going to first describe the top part of the program, and then we'll just look at the G00 command within the program. We will we'll go through all the various command lines, and then we will get to know what each of them means. Now, when you take a sample work program, if you're writing a CNC program, the first thing you do is first to give the size of your blank. That is the workpiece that you are going to work on. The blank size, this one is saying x6, y4, z1, means the length, breadth, and the width is given in this fashion. And then the tool that you are using has a number. Normally the CNC machine has an indexing head that holds the tool. Now each of these tools have a tool magazine that these tools are installed. So the magazine has an indexing that has numbered the tools. So you have a tool in an index position 1, 2, 3, and all that. So each tool has a number. So if you say tool 1 or tool number 2, it may be assigned to a particular tool with a particular dimension. So for instance, in this case, we say the tool is tool 2 and it's a 1/4 inch slot drill, and then we have to label it as such. Then it is important when you are writing the program to actually identify the start position of the tool. So in this case, our tool start position is x0, y0, z1, which is x0, y0 means z1 means the tool start position is this coordinate position. Now, if you want to initiate any CNC program, to start it, you have to bring this percentage sign to show that the program is starting. That is the program start flag. Then the next is the program number, which is like the program name. Every program written in the CNC machine has to have a number that you use to identify which program, which is program 1 or program 2 or 3, or as the case may be. Then you have the first line. As I explained previously, all these n values you see in front of the command lines are all line numbers, and the line numbers are such that you can actually use the order of 5 series to number them. So if you look at this, it's line number 5, 10, 15, 20, 25, and the likes up to 65. So that clearly shows that this is line number 1, 2, 3, and all that. So once you use the line numbers have no impact on the syntax. That is the codes that we are going to explain. Now, we'll go to each of these codes as we proceed to explain the command. But if I take this simple or sample program to explain this, I'm just going to explain up to this point. If you are issue a J90, a J20 command, a J90 is absolute programming, which means I'm programming with the absolute coordinates, and that is starting, each coordinate will pick its value from the origin, and then that is if I want to measure any coordinate, it is measured from the origin, which is a fixed origin. And so if I issue J90 in the command line, I'll say that let the program settings be at absolute 0, that is absolute coordinate system. That is, I am referencing all my coordinates from a fixed origin. Then if I give a J20 command, then I'm programming all my coordinate values in inches. So J20 means inch programming. Then if I give an M06 command, M06 means to change. We will take each of these commands one by one in the subsequent slides. And so this M06 means a to change, and the next letter that follows the to number, so it means to change to number 2. Now this command, if we come into explain it further, I will explain the subsequent miscellaneous command slides. That is, if you use M06 and say to change, M06 is either used for a to change or selection of a new to. So if you give an M06, especially at the beginning of a program, it means that though you're doing a to change to whatever to was being held by the to post, to change it to the new to, which is a T number number 2, that is a T2. Then an M03 command is actually to turn the spindle on in a clockwise direction. And then if you give a speed to the spindle, then you put an X before it, it will be S, let's say for instance in this case 1200. It means that you have turned the speed to 1200 RPM. Then you come to the command which is the G00, which says G00 X1 Y1. Then it means you want to move the 2 from wherever it is, which is the start position X0, Y0, Z0, to the position X1, Y1. Now note that we did not state the Z value, but what it means is that the Z value still remains the previous value, which is the start position value of Z, which is Z1. So this can be X1, Y1, and Z1. Even if we don't write a Z, it clearly shows that the current position is X1, Y1 plus Z1. Then if I put the next line to say line number 25, Z equals 0.1, because this is the first command I've given, the J00 command, it remains active until another command comes in. So J00 command so active here. So Z0.1 means I will have to move down to 0.1 from 1 closer to 0.1. Okay, I will leave the rest of the program because we will go through each of the command lines so that you understand it better. Okay, so next we look at the next command, which is a J01. J01 is a linear feed or a linear interpolation, and the format is you give the line number, you give the command J01, then you give the final coordinate designation x1, x, y, z. So whatever values you have for x coordinate, y coordinate, and z coordinate, you put them there. In addition to that, you have the feed rate, which is characterized by the letter F, and then the number that follows it will be stating the number or the feed in inches per minute. So that has to be taken note of. So you have the feed rate in inches per minute. So the G01 is specifically a linear removal of material from a workpiece, and in any combination of X, Y, Z. It does not mean a linear move, just a straight line move, but it can go in any linear fashion. So let's watch this video to see how a G01 command is.
The G01 command is not limited to one plane. 3-axis simultaneous feed moves, where all 3 axes are used at the same time to cut different angles, are possible.
So what it's saying that it is not only used, as you saw, for simply, if you like, if it's not only used for, as you saw, for simply linear feed move, but you can have a move in the 3 axes, which is X, Y, Z, and then it will turn something like that. You'll notice that this is a 3-dimensional movement, which is X, Y, and then some Z, and that is what a G01 command can actually execute. So for instance, if you have a sample program, and let's say we give the command, all these parts we have really talked about it, but if we give a G01 command, that's the last command down here, G01 Z minus 0.125 F5, then it means we are feeding down in the Z direction at a feed rate of 5 inches per minute. So we put F5 there. Okay, that is what this command line means. G01 means feed, a linear feed, and the Z is minus 0.125 at the feed rate of 5 inches per minute. Okay, so that's just something that we want to talk about. Now, if we feed at that rate of 5 inches per minute, now if we look at the next line, which is saying X3, Y2, F10, it means we are still using the G01 command because it is not cancelled by any other G command yet. So we are still using the G01 and saying we have to feed X equals 3, Y equals 2 at a feed rate this time of 10 inches per minute. Then we can do a rapid movement. This is a rapid movement to a position, and then another rapid movement to X0, Y0, and you have a spindle off and then a program end. We will get to the other definitions, but we want to just look at the G01, and then it means that on this command line we still have G01 active, but the feed is 10, and then that is 10 inches per minute. Okay, now the next command we want to learn is the G02 command. The G02 is a circular interpolation in the clockwise direction. For a G02 command, basically you want the tool to actually cut in the form of an arc move. Okay, then if you want to give that command G02, it's also a modal command. That is, if you give it, it is still active until it is cancelled by another command. Now, if you want to give the G02 command, it requires some information that you need to supply. So, the format of the G02 command, as you can see from the slide here, it's a circular interpolation in the clockwise direction. The format is like this. You have N, which is the line number. Then you come to the G02. That is, you give a G02 Then you have the coordinates, x, y, z coordinates, position. And then you have I, J, K, and then we have the F, which is the feed rate. So I'll talk about the feed rate and the IJK shortly. But what the G02 actually requires you to do is that if you give the G02 command, it requires an endpoint and a radius in order to cut the arc. If you want to cut an arc, you will have a start position, you will need an end position, and you need the radius of the arc that you are creating. So if you know the start position and you know the end position, you can simply find the radius of that arc by measuring the distance, the incremental distance from the start point to the center point. Okay, so from the end point you'll be able to see the center point, and then you can measure from the start point to the center point. That gives you the radius of the arc. So let's look at a typical illustration of this G02 command. So for instance, if we want to give a G02 command, we say, okay, let's use this sketch here as an example. We have a milling cutter at the start position here. Okay, so we have a milling cutter at, let's say, this start position 1, and we want to cut this arc, so to this position 2. Now what we need to do is to be able to define the center of this arc to generate the slot that we have here. Okay, so for us to define the center of the arc, we need the center point here, which is the coordinate for that center point. So we know the start point is this coordinate position, which is 1, x equals 1, y equals 2. Then we need the center coordinate. The center coordinate for this arc is x equals 1, y equals 1. So this will be the center point x1, y1. Then we have, so this side is 1, obviously is 1, 1. Okay, so we have x1, y1, and then we need a start point which is x1, y2. So we do a quick subtraction, and we have 1 minus 1 will be 0, and then 1 minus 2 will be minus 1. Then we attach this vector coordinate system to it, which is the I and then J. I is for X and then J is for Y. So like if you remember your vectors, you have I, J, K representing X, Y, Z. In this case we have X and Y coordinates, so we have to just attach I and then J to show the radius as I 0, J minus 1. So in this format that you see J02, X, Y, and then Z, we will have J02, and then we give the final destination of the arc, which is the end point, and then we give the IJ, which is the center, or if it is in the 3 dimension, we will have IJK. So we will have the center of the arc, or the radius of the arc given by R, I, J, K, and then we put the feed rates there. So a typical example or a typical show of, let's say, a J02, a demonstration of a J02 is what we're going to see now. Like if you give a J02 command, let's watch how the command comes out.
Circular interpolation is more commonly known as radial or arc feed moves. The G02 command is specifically used for all clockwise radial feed moves, whether they are quadratic arcs, partial arcs, or complete circles, as long as they lie in any one plane.
So this is how the J02 command actually moves. If you look at it, it moves in this clockwise direction. Now, depending on the start point and the end point, this circular interpolation in that clockwise direction, if it comes back to the same point, it will generate a full circle interpolation. So depending on the final coordinates that you give, you will have a full circle interpolation. So just as I was explaining this, how to work out the center or the radius, which is the ijk, the steps are here to find the I and J values. It's easier than what you probably may think. The first step is you write the X and Y coordinates of the arc's center point down first. That is the start. Then below these coordinates, you write the X and Y of the arc start position or the start point. Then you draw a line below to separate this. Then to find the value, you calculate the difference between the arc start point and the center point in the X direction, and that will have the values, and that will have the I. Then you will have the difference is 0 because each one has a coordinate 1. And then you find the J, you calculate the difference between the arc start point and the center point in the Y direction. And in this case, the difference between that Y2 and then Y1 is down 1. So that is -1. And then you get your I and J values as I explained previously. So just once again, this is how the command will move the 2 in this fashion. And then if you give the start coordinates and the end coordinate to be the same value, then the 2 will come back to the same point and it will cut complete circle. Okay, I want us to look at a sample program, and then we will look at the next command, the third one, and we will probably wrap up the section for tonight. Now, a sample program of the J02 command. A J02 command, we have a J02 J90. Let's look this example. Now, if we have this workpiece, we will give the workpiece size, the 2 number, and the 2 type. We will type the information. We have the 2 start position. We have this percentage to show the program start flag, and then we have the program number. Now, this gives us the coordinates, the system that we're using, absolute coordinates, inch programming. We have a 2 change to select the 2 number 2. Then we turn the spindle on with this command M03 at a speed of 1200 RPM clockwise. Then we have a rapid movement in the XY, X1, Y1 direction. Then we feed another rapid down to Z0.1. Then we give a linear feed J01, which is a linear feed with a feed rate of 5 inches per minute. Then we give a J02, which will do X2, Y2, and then the radius is 1, 0. The X, the difference in the center, and then the start point is X, the radius is 1, and then we have J 0. So the radius can be measured as 1 in the J direction, in the X direction. Okay, at a feed rate of 20 inches per minute. So wherever the start point was, the start point will be at X1, Y1, because that is the final X values that you can see there all these are z values. So the x1, y1, and then the end position will be x2, y2, x2, y2. Then this is showing that the difference, that is the radius, is detected by the difference between the start point and then what? The center point. So we can use this to actually find a center point coordinate by doing a simple evaluation, and we can get that. But what we want to do now, we are not just executing the commands, we want to understand what the commands are. So it means that it will move to the end coordinate, which is x2, y2, with this radius I1, J0 at a feed rate of 20 inches per minute. Then if you use another command, J01, then it is going to do a linear move instead of a circular interpolation, which is J02. So that is an arc feed to x2, y2, and with the arc radius of 1. Okay, now if you use this command J02 x3 y 0.5, and this time instead of ij you use r, which is the radius, and say the radius is 2, then basically if you use the radius, then you are talking about doing a complete circle if the coordinates position that you give x3 y 0.5 is actually going to come back to the position where the x values were before. So the current position of the x is 3.5. So if you give an x equals 3 and y is equals 0.5, the radius of the arc is 2. Now, just to go back to explain something, you can decide to use the R or the IJK format for the J02. That is, we're saying that I and then J talks about the radius of the arc. Or instead, you are using the radius R is equal to, if you know the magnitude of the radius of that arc. Now, we normally use the IJ because if the arc is not a complete circle, sometimes if you use the R, it picks it as if the arc is a complete circle. But if you use the IJ, if you are doing an arc to any radius, it will pick it and define the arc. But if you use the R2, which is a radius, then there's a chance that the interpolation may create a full circle interpolation. So yes, we can use the R instead of the IJK, but we have to be careful. If we are sure that it is a complete circle, then we are free to use the R. But if we are not doing a full circle, then we may be cautious here by using the IJ. Now, for instance, let me just show you a command line number 70 here. Now, the command line number 70, if you look at the J02 command given here, let's look at the last x coordinates values. It's x2, y 1.5. Then we give a J02 command to come back to that same position in the clockwise direction. It means it is going to do a full circle interpolation, and we're given the radius to be 0.25 I and then j negative 0.25. So it's doing a full circle arc feed move in the clockwise direction, because the x coordinate here, as you can see, is 2, and it's the same 2 here. The y is 1.5 and it's the same 1.5 here. It means that you give the J02 command to come back to the full circle. That is, come back to that position. And if you give that command, then you are going to have something like what I'm going to play in this video for you to see. That is, you have a situation where the two will cut through with that specified radius until it comes back to that point to create what we call a full circle move. Okay, so let's look at the next command, which is the G03, which is just like the G02, but this time this is a circular interpolation in the counterclockwise direction. That is, we are looking at it in the counterclockwise direction this way. Now, the same way, you give the G03 command and you put the final coordinate designations. That is an x1, a y1, and that. So you give the G03 command, then you have the final x1, y1, and then you have the radius, the I and then the j values, just like we computed. So you have the center point minus the start point values, then you have the I and then the j values. So they work same as the J02, just that the interpolation is in a counterclockwise direction. So just like this, right? So this is an interpolation in the counterclockwise direction. I believe you saw how the two moved. The two actually moved from this direction.
The command is specifically used for all counterclockwise radial feed moves. The G03 is also modal and is subject to a user-definable feed rate.
Okay, so it is a counterclockwise feed move. The two will travel in a counterclockwise fashion, and all other things about it remain the same, just as that of the G02 command. So let's look at the G02 command or G03 command format method. Now, if we are in the G0, we are operating in the XY plane, then you will have the format of the G02 or the G03 command will have an XY values, and then we will have an IJ as the radius and the feed rate in the XY plane. If we are in the XZ plane, which is with the command G18, which tells you that you are in the XZ plane, then we will be programming using X and Z values, and the command, the radius will be I and then K, standing for the vector coordinates for the X and Z. If you are in the YZ plane, then you will be using the Y and the Z coordinates, and the vector coordinates will be J and then K in the YZ plane. So we have to take note of this. Now, if we are using the radius method, with the IJK method, if you are using the R method, which is the radius method, then if we are in the G17, which is the XY plane, we basically use the X and Y values, and then we can put the radius values there, and then the feed rate. That one is not really affected by the IJK, so you can just put the radius values there. Okay. Now, because this format is basically on here, this command, let me just talk about the next command, which is dwell. Dwell command, briefly, is we say it's a non-modal dwell command that halts all the axis movement for a specified time. Let's say we want the tool to dwell for, let's say, 2 seconds. Dwell is very important, or it's a very important command Now, when you use dwell, basically you commanded the tool to remain in the position that it is without any movement down or the axis. So it stops the axis or the axis movement, and the tool will still be rotating. The spindle will still be rotating. So let's say if we want to demonstrate dwell in a sample program, dwell is very important. Sometimes you do it where you have a lot of you have an operation which is let's say a drilling operation where you have created a lot of debris or chips, and then you do it in such a way that at some point within the feed operation you dwell a little bit for the chips to clear on the workpiece. So if you write a program and you want to introduce dwell, like a pause for some clearance to take place, all that you do is basically using the line command. Let's say this is the dwell command. We will say that, okay, on this line we put J04 P2. It means you want the tool to dwell for 2 seconds. So it will just be on that axis. It will not be moving or rotating. It will be rotating on the axis, but it will not be moving down or up or along any axis for 2 seconds before it will take another move, either up or down the axis. So dwell is just a J04 command with a letter P, and the number before the P is the number in seconds. So if you have 2, you have 2 seconds, 3 seconds, and all that. So let me quickly talk about this XY plane that we have been using. That is, if we are working in the XY plane, then the command line that we issue is a G17 to show that the tool is working in this XY plane, in this plane. Now, if the tool is actually going to cut in the YZ plane, then we have a J19 command that we issue to show that this tool will be cutting in the YZ plane. That is, in this plane, the tool will be cutting in this plane. If the tool is cutting in the XZ plane, that is this plane, then we will issue a command before the beginning of the cutting process as J18 on the command line to show that the plane will be in the XZ plane. Now, depending on the plane that you select for, or the plane that you have oriented the workpiece for cutting, the G02 commands and the G03 commands can have a different orientation. For instance, if you take the XY plane, then of course the G02 is clockwise interpolation, G03 will be counterclockwise, so which is fine. If you come to the YZ plane, same way the G02 is clockwise, the G03 is counterclockwise. However, if you come to the ZX plane, normally the plane here is the ZX plane. Okay, so if you have a ZX plane, this plane, then you are going to have a situation where the G03 is as if it's the clockwise feed or circular feed, and then the G02 is the counterclockwise. It only happens in the ZX plane. So when you are programming, you have to be sure which plane you are programming. And if you want to do a clockwise move or counterclockwise move, especially when you are in the ZX plane, that move can mean a different direction. Okay, so basically this is where I want to end up the lecture for tonight. we'll continue tomorrow. Thank you very much for staying with me, and I will see you tomorrow.